Okay, I think the least confusing way to do this, we're trying to find the value of t at which the value of the function at 1/2 doubles. So here's t equals 1/2. Here's the value. Okay, the value would be this, right? Be this. And I can represent that value by just, I'm going to use an arrow. Okay, the length of that arrow is the value, right? Now, what could I do to find twice that, to represent twice that value? Well, I could just take that arrow and slap another one on top of it of the same length. Right? And then I could come over here and I'd get this point, right? And then I project that point down and I say, okay, between here and here it looks like this function should double, right? Does that make sense? So that doubling time not very well written. Board's a little rough, and I'm a little incompetent. Okay, this is the doubling time, right? So then you could estimate that numerically. Well, this is a little past the midpoint of the interval, right? So you might estimate it's 1.2. It'd be a perfectly okay estimate. It's off by a little bit, 20% or so, but it's not an unreasonable estimate, and just doing that in terms of the arrows. Now it looks to me like, and when I look at this again, if I take the length of this, it looks like I went too high. So maybe I overestimated this. Anyhow, make your own estimates for t equals -1/2. Okay? You will see that your graph gives you reasonable results. Just a hand-drawn graph. They're not exact. They're not totally accurate, but they're probably good within plus or minus 25% a lot of the time, maybe much better than that, depending on just how good you are at drawing an accurate graph, okay? And I'm not interested in your talent for drawing an accurate graph, although I hope you both have it, okay? Just the idea of understanding the graph well enough to answer these questions, okay? Because then the calculus will make much, much more sense to you. Then we're going to get into the calculus here in a minute.